Well, hello there, community. This is actually take two for me because I got like 2 minutes into the show and I was like, oh my gosh, I forgot to hit the live button. So you get take two. I apologize for starting the show just a little bit late. I was like all prepared. I set up buttons on my stream deck and like, oh, we got this today. And then, excuse me, I missed the most important thing, which was actually to be live with you. So welcome. We are professionals here. My name is Jason Rom. I am your host for this episode of DevCentral Connects. And today we are going to talk to Joel Moses, F5 Distinguished Engineer, about the Open Programmable Infrastructure, a new effort by the Linux Foundation that kicked off this summer. So you'll get to hear about that and all the excellent things that are coming. Before we do that, I'd like to do a little bit of house cleaning and house cleaning. What is it? House cleaning or housekeeping for you? Maybe drop that in the chats because I hear it both ways. For me, it's always cleaning. But anyway, October is Cybersecurity Awareness Month. We are on DevCentral at community.f5.com. We're going to have a lot of great content over the course of the month. Rebecca Maloney, our content manager, put together a great program. So I'm really excited about that. And we have on October 19th, the quarterly security notification is going to drop. And more about that a little bit later in the show when we cover the news. And then the code share is back. Excited about that. We've heard feedback on DevCentral. We have ability for you guys to drop ideas and make suggestions. One of those from the very get-go, there was some confusion about crowdsource and what that is, and can we just have the code share back? So, we took that under consideration, and hey, it's back. So excited about that. And then finally, DevCentral featured member Pascal Cuppers. Apologize if I butchered your name, but we're very, very thankful for your contributions on DevCentral, and for those of you who want to see the people who are making an impact in the community. You can go read that article on DevCentral. To bring my co-host for the day on, Boo. Boo, how are you?
I'm good, Jason. Good to see you for the first time today.
The first time, right, the first time.
Yeah.
Yeah, so, we're going to talk to Joel. We're going to kick that off because that's another part of the feedback that we got from the community here on DevCentral Connects is like, hey, we love the chit chat, but, maybe we can just get to the brass tacks a little bit earlier in the show. So we're going to do that today. But I don't know if you had any thoughts about our discussion with Joel before we kick that off.
I think it's important as we move into cloud and people are thinking about, hey, what's my position as far as where my applications lie? Well, there's advantages to hosting your own data center still when you can take advantage of things like XPUs that Joel will talk about here. And inside of public cloud, those options can be available as well. But I think people can kind of accelerate their business and create advantages if they look at this strategically. So I think it's an important conversation.
Yeah, me too. All right, let's get to it.
Cool.
Today, we have the esteemed Joel Moses, F5er, with us today. And we're excited. We're going to talk about the Open Programmable Infrastructure, OPI project. And Joel, just to get started right off the top, what is OPI?
Well, like you said, it stands for Open Programmable Infrastructure, and it's a Linux Foundation project that was initiated by a number of different parties, the founding members being Red Hat and Intel and ourselves. We were able to entice a lot of other competing entities to also tie into this project under the promise of what an emerging market for something called DPUs or IPUs, or if you want to just abstract it, it's XPU, right? These are specialized pieces of hardware that we're trying to create an open marketplace for services on top of, and that's the whole intent of the Open Programmable Infrastructure project.
Okay, so that's, I guess, shocking would be a term. We're bringing competitors together. That does not sound intuitive. Why is that important?
Well, it requires you to go back and look at a little bit of history in the networking space. At the very beginning of all of this, we had network interface cards, and those cards fit into general purpose computers, and they did a networking task, but they did a very basic job with it. And then NICs started to get a little bit smarter until we got to the present round of what they call smart NICs. And smart NICs are an interesting beast. A lot of companies like Intel and NVIDIA, for example, they make smart NICs. But these smart NICs, they accelerate a portion of a networking task, and they tend to do so in different ways. And so we support smart NICs at F5. We work really well with them inside of our Big IP VE. However, we have noticed as the service provider for our various services that it's very difficult to get onto the train of a smart NIC and to support all the various versions and sometimes even the production runs of individual cards. There's differences in the way the software composites, there's differences in drivers, there's differences in how the hardware functions, and we have to keep up to date with all of that, and we have to custom craft things. It takes a lot of time. It takes a lot of skill, and we do that. However, smart NICs have not taken off like everybody thought that they would, and the reason for that is because of this pain that every ISV goes through when they try to integrate with a smart NIC. Now, these smart NICs are getting smarter, and they're turning into these things that are being called infrastructure processing units or data processing units, which essentially are, if you take a smart NIC and you put a little general purpose CPU on it, and you tie that general purpose CPU into the complex on the card becomes an environment unto itself. It's something where you can run code, you can run containers and various other things, and you can tie to the hardware that's on those cards. The card then becomes a place where you can host things, and more importantly, it becomes a place where you can abstract away some of the driver version differences and hardware differences. And it was the transition into this space of technology where we noticed for the first time these smart NICs turning to DPUs were getting much more capable than ever before. And all we really needed to do is try to convince people to do things in a common way on these types of hardware. We're very excited about DPUs, by the way, because DPUs look almost identical to how we engineer appliance platforms. I'll share a little bit about that. If you think about a DPU, think about it in terms of a transparent server that's sort of plugged into another server across a bus. So this is how these cards are designed to work. They have general purpose CPU, and that's butted up across a PCI bus to the CPU that's in the server node. And the DPU has a little bit of storage. It has a network interface. It has other accelerators that are on it. And so the card can present itself to the underlying server as a NIC. It can present itself as a disk controller. It can present itself as a serial device. There's a ton of different ways that the card can expose its resources to the underlying server. Effectively, the DPU allows you to take and create an infrastructure zone and layer on top of your general purpose compute infrastructure that is completely separate and isolated from the underlying compute. That is a really enticing thing for certain customers, especially customers like service providers or financial services companies that want to provide a base level of infrastructure support through the network, but they want to isolate the actual applications, and DPUs are looking very exciting for them. So because these cards have to run code and they have to run services, they have to have a way to inject something onto the network interface and present itself to an underlying host. They are engineered. They are designed. If you look at a block diagram of a DPU and a block diagram of a big IP hardware appliance, they look almost identical. And so this is essentially like taking a big IP and stuffing it inside of a slot. So we're very excited about it. Now, we knew, though, that we had a lot of different vendors, Intel, Marvell, NVIDIA, AMD, all producing these DPU cards. They all have either cards on the schedule or they have cards in production and shipping today. So we wanted to get ahead of that. And we wanted to create something that allowed these cards to be used and for our services to plug into these cards in a way that would work across vendor platforms. And that's what the OPI initiative is about.
So when it comes to the OPI initiative, we see the benefit of doing this in an open way and working with our competitors. Is this something that F5 would have found really hard to try to pull off on their own and make it potentially proprietary and make it a business advantage as opposed to being open about it?
Yeah, so we're obviously, by creating something that is generally usable by ISVs, we're opening the door also to our competitors to produce services for these same cards. But we think that a market for these cards raises all boats. Okay, so think about the power of having this type of hardware available inside your infrastructure, where you can offload all these infrastructure operations to the card and not impact the underlying compute for your application. It's exciting. It speaks to some long-held desires, both in enterprise and hyperscaler and service provider space, that we've heard. And so the difficult part wasn't, by the way, convincing ourselves that we might open these things up to competitors. The difficult part was getting competitors who produce these cards to realize the importance of working together to create a common infrastructure. And that is what the OPI project is about. And we're pleased to have Intel on board. We're pleased to have Marvell on board. We're pleased to have NVIDIA on board. They are good partners. We're pleased to have Pensando from AMD on board. Everybody has come to this party, and we're very happy about that.
As far as our attack angle for how we, engage with the cards themselves, are we taking an engineering mindset to providing direction on the cards, or more of, oversight and steering? Like, will we have a play in? You mentioned that Big IP as a card, that would be what it is. Are we engineering cards, or are we just providing steering for that?
No, we're providing steering for that. We see a lot of great momentum within the equipment providers, within the hardware manufacturers, to produce really good quality hardware, things that run with low power budgets. Remember, these things have to fit inside of a server, so you don't want them to exhaust the power capacity of the bus that they sit on top of, right?
Yeah.
So these cards are almost universally based on the ARM processor, but they have, some of them have 64 cores of ARM available for doing work within these cards. On top of that, they have FPGA complexes, and they have crypto accelerators. They have storage acceleration capabilities. There's a ton of things to like about them. And what we're trying to do is allow the equipment providers to produce and enhance and release these cards at a rapid pace, while the OPI kit that sits on top of it will give us a stable environment in which to produce our services. So all we have to do is just sit back and watch as the vendors accelerate their hardware destinies, and our software can run and take advantage of new enhancements as they come along because of the marketplace approach.
So with the OPI kit itself, is that something that is installed at host level, and then your services running on top of that take advantage of? Or is that something that as you deploy your package, it takes advantage of that and embeds?
Yes, you caught me here. So the OPI project is newly initiated. We initiated it in July, and so the teams have come together, and they've first completed a common taxonomy for the cards. They are working on common API sets. NVIDIA donated their Doka toolkit to the project as open source. Intel introduced as open source to the project the IPDK project. So we're assembling a lot of different constituent parts right now. In the end analysis, what we're hoping to get to is a common API set and a couple of reference architectures that can be used to produce what we're calling an OPI compliance factor for the cards. What form that's going to take, we're still working on that. And that I want to be also pretty clear about this. We need other people to come work with us. Okay, this is a fast-moving open standards project under the Linux Foundation. It has a lot of attention. There are a lot of people who are coming to the project and contributing to it. And we want not only other service providers, but we also would love our customers to get involved. One of the things that the OPI project is trying to do is collect, collate, and introduce use cases for this technology, so that when we produce designs, those designs are custom tailored for the use cases that customers bring us. We have participation from people like Comcast, for example, in this project, and we're really happy to have them.
Yeah, I remember filming a light board for the Smart NIC stuff that we introduced years ago.
Right.
And just to see the power of purpose-built compute within a general compute environment for the services that right on top of that was exciting. And to see that, the emerging markets that are coming with additional services on top of what SmartNIC provided is exciting.
Right. Absolutely. Yeah, we're very intrigued by the possibilities here. And we've had a lot of customers asking us, well, what are you going to do about these things that are coming out? So we're trying to get ahead of that in a way that's going to benefit the entire industry, not just F5, but in benefit the entire industry. We think that these cards could potentially be game changers.
You would think, in the game of cat and mouse when it comes to cybersecurity, and let's say you have a SaaS platform that has web application security from an AI and ML perspective, and if some of that can be pushed down to an XPU, hopefully we start gaining an advantage in cybersecurity as opposed to always kind of catching up to what attackers are doing.
Yeah, absolutely. We've been doing a lot of thinking within the OPI teams about how to create a denial of service control infrastructure that allows you to assign DPUs to mute out a denial of service attack and then return DPUs back to an unused or idle posture once you're done with it. This is spare compute that you can provision, stand up, cluster, distribute across, and then shrink back down. And the cool part about that is you can handle the denial of service task right there on top of the server without affecting the underlying compute that the application runs on. The application doesn't even know that there's an attack underway. Instead, the card is aggressively handling that for you.
Alrighty. So actually great transition there. So there's a full-length version of that discussion that is on the YouTube channel for the DevCentral YouTube channel. So youtube.com/DevCentral. The additional part of that interview, we actually talk about ARM architecture a little bit here. It's always great to hear from Joel. So you want to check that out as far as the full interview. And something that I've been talking about for the past few weeks has been the book written by Joel and his team in F5's Office of the CTO, which is Enterprise Architecture for Digital Business. So I actually sat down with Joel, or virtually sat down with Joel, discussed what his chapter was all about, which was about the XPUs. And in a second here, we'll just actually roll a little bit of a clip of promoting that book and where to go find that full interview. So I'll let our producers roll that in a sec. For 3 centuries, the Renaissance drove renewed interest in classical philosophy, literature, and art. As the third wave of the internet washes over the technical foundations of digital business, there's renewed interest in classical infrastructure compute, network, and storage capabilities, particularly at the edge of the network. I've been having discussions with the authors of Enterprise Architecture for Digital Business. And in this discussion, I'll be speaking to Joel Moses, Distinguished Engineer and Chief Technology Officer of Systems at F5. He's the author of Chapter 2, An Infrastructure Renaissance. He explores infrastructure and the standards that will impact the future of infrastructure architectures, like the ecosystem forming around ARM architectures. He talks about 5G and container native workloads. He uncovers the hidden advantages of the XPU industry, which is driving unprecedented power into the edge. Most importantly, he will examine how organizations can take advantage of these advances in a digital enterprise architecture and how public cloud and edge computing play a significant role in a modern view of infrastructure. It's always a pleasure to chat with Joel, and I hope you enjoy this discussion.
Yeah, so if you have not picked up your copy of the book, make sure you go do that and go check out the full interview. In fact, we're going to cover some news now and an article that came out this last week or this month. Let me see. Yeah, actually the 23rd. So we're 4 days ago. It was interesting coming out of our conversation with Joel talking about the ARM architecture that most of these XPUs are being built on. And so, I'll get to that here in a second. But before we do that, I have our correspondent from the upstate New York area live, Aubrey. Wow.
Hey, guys.
How are you today?
I'm doing well. How are you guys doing?
Doing fantastic. What do you got for us today?
Well, really quick, while I was out and about taking a couple of shots for some features I'm working on, I wanted to just make sure to remind all the viewers that we do have a quarterly security notification coming up on October 19th. We already have a pop-up show scheduled for the 19th, so if you're around on Wednesday the 19th, don't forget to tune in and make sure that you are kept up to date on everything that's going on with any of the vulnerabilities and disclosures that we release on that date.
Awesome. Thank you so much for joining us from location. That's pretty fantastic.
Yeah, you got it. I wanted to make sure the 5G was good enough to do this a little more regularly.
Yeah, it looks fantastic. So that'll be cool to have like a field correspondence. That's kind of cool.
Hope to do it more.
All right. Take care. Fly,
Thanks, guys.
Look at me. Take care, Aubrey. Yeah, that's really cool. All right. So, my first, I'll bring the news. Oh, did that wrong. There we go. My first article is a history of ARM, which is pretty fantastic because I like have Raspberry Pi and you hear about ARM all in the news, but I have a pretty good understanding of the history of Intel chips, but for ARM I didn't, and so right out of the gate here a few days ago, a history of ARM part 1. The part 2 will be coming, but they go through all the crazies from the very beginning of the why they wanted to go that, and the risk-based architecture, and RISC is the reduced instruction set, and so fantastic article. It's a great read, so I recommend you go out and do it. And one of the things in this article, it's like I got my degree in aviation, but early in my coursework, I had started in engineering, electrical engineering technology, which is kind of a hybrid of an operational degree path and a design career path. So it was kind of a merged, degree before I switched to aviation and avionics. And so one of my favorite classes was logic gates, and so you had an entire semester of truth tables and gates and building gates out of gates, and you can pretty much build every gate out of a NAND gate. And so we went through those exercises and all that. But in this article, they talk about the gates and carry bits and being able to build registers, and then they have all the instruction sets that they would have in their architecture. And so it's a fantastic read if you like to nerd out on nitty gritty details. But one of the things they link in that article, and this is kind of my second one, which is just like, nerdy about logic gates. You can actually come over here and see how adding with logic gates works. And so if you come in here, you'll watch, and they've got like 100 millisecond propagation delay. So you click this, and I don't know if this will show up on video, so you'll have to go see the article. But you click, and then it works its way. The logic works its way through the gate, so you can see, okay, I've got a one, or a one, depending on which one you go in. Some's going to be one, but if you do two, it's going to be zero, and that's where on this next one you need you need your carry bit, and to be able to register that you've gone up a level. And so when you're carrying in mathematics, you carry to the next digit, then that goes back to zero, and your carry bit came over to the next one, and so on and so on. You get down here, and then you can see all that logic builds out over time, and you get up to however many thousands, millions, and billions of transistors. But that's where you're going with how compute works, and how they put all that down into the silicon, and all that. So anyway, we'll link these articles.
I have a feeling that this might appear on the next escape room, Jason.
It probably will, yeah, because I can do that kind of logic on the escape room stuff. By the way, the escape room, even though we're not in National Coding Week, the escape room is still live, so you can go play. And there's been a few of you who have made their way out of the room, but not very many. It's been small, so maybe I made it a little too hard, or maybe people just got into it and it's like, yeah, I'm not going to do this. So
Maybe I'll post my time and it'll inspire folks to beat that, because I'm pretty sure most people will.
yeah. Okay, so you have some articles as well. Before we get into yours, I did want to announce the SOAS survey, the State of Application Services, that that is live for just a few more days, I think. And Peter, if you'll drop the link into the chat, I'll play your little promo here.
Hey folks, it's that time of year where we're asking for your participation in F5's 2023 State of Application Strategy Survey. We'd love to know a little bit about your infrastructure and systems. Be asking things about automation, application performance and delivery, visibility, all the things that make applications run smoothly. We'd love your help. It's done by a third-party vendor. Everything's anonymous. Nothing's going to leak out. You'll get the results, copy of the results after, and we actually share the results out with the entire industry. So we'd love your participation. Check out the link and be a force for the digital world. Thanks a lot.
Good to see Jimmy.
Okay, I did not know that was going to play like that, but that was kind of fantastic. It's like kind of just split the middle of the screen, and we're able to still be on. That was kind of cool.
Yeah.
All right, so Boo, you had an article here.
Yeah. This one's a good one, written by Datadog, actually. I don't know if they're a technical alliance partner, but I got a good buddy over there, Ryan McLean, who is one of their developer advocates there. This is not written by him, but this person here took the time to outline some of the security features that were released in Kubernetes 1.25. So for anybody who's adopted that already, you have some really cool things to look forward to on pod admission, identification of operating systems, the CVE feed. It actually now has a feed that has all the CVEs that are listed in a JSON format, which is nice. Network port ranges when you're exposing pods, user namespaces. So I think there's always a concern around pod escapes, and maybe some of that has to do with how you have to architect security in order to execute certain functions, and they're starting to build that in, so that's more of just kind of a built-in function, less workarounds, and maybe that will help people with their architecture for pods. So just a really quick one, but something that everybody should find some good info on if they're running Kubernetes.
Awesome. One of the things about Kubernetes that I guess I've heard about it for so long. It's shocking that it's still just v1.25, right? because most like open source projects, you're pre 1.0 for a while, but then once you hit your first major version, it seems like it goes a little quicker. But it's one of those projects that hit the ground running really fast, but really it's not been out that long. And
No, I think they're very, very good about governance. That's probably a very good example when it comes to open source governance across a lot of vendors and a lot of people. It did wonders when Google turned that over to the CNCF. It turned it over to the Linux Foundation and made the core of the CNCF with it. So they're kind of a poster child, and now the CNCF is great at incubating other projects that have to do with Kubernetes. So great to be a part of. But if from an open source perspective, if people want to contribute to something, that's the thing right now, is getting into CNCF and generally Linux Foundation stuff, like the OPI project ties us all back.
for sure. All right, and then you had another one here.
Yeah, this is just an interesting one. This has been in the news for the last week or so, is the Uber hack. And it was just kind of interesting if you follow that. And again, like over here, we're not saying anybody's bad for getting hacked or anything like that. We always want to learn from these things. But one of the things that we're seeing here is the attacker, perpetrator, is the same person that was the one that actually broke into Rockstar Games and stole Grand Theft Auto footage and released that ahead of time. And it was a 17-year-old in the UK. So it's amazing to see, yes, that's a bad thing to do, but at the same time, it's amazing to see like a 17-year-old hacking into very big companies and exposing this kind of stuff. You can get, all through the years, people that are very young have gotten themselves into a lot of trouble, but this is really interesting to see.
It's interesting to see, and also it's like, man, we gotta shape these, get the hands on these young people and help them to be productive in a good way. And
Yeah.
so
Well,
hopefully, go ahead.
if people know the history of application app level encryption with our advanced web application firewall product, they would know that that came from a company called VeriSafe that we purchased out of Tel Aviv, and might know that the founder of VeriSafe, I believe at the time of the purchase, was in his early 20s, but his claim to fame was actually when he was 14 years old, he was breaking into ATMs,
Yeah. Well, there you go.
hacking into ATMs. And then he was hired, I believe, either by the bank or by the government. So they gave him a job because he was very good at security, exposing security, but then hired him to do good things. And then he went on to create cool products.
Yeah, and you've seen that throughout history, like Mitnick and even in the financial industry, Frank Abagnale Jr., who was really really good at fraudulent check writing, and
Hmm.
he was brought in by the FBI to help them, you know, catch other guys, but also to design, um, you know, currency and all that into, uh, you know, making it better.
Yeah. Just channeling that energy for something good. It's great to see.
Yep. All right. Well, that's the end of the show, and of course we're running a little bit behind because we had a false start at the top of the show, which is
All
I'll,
good.
I'll own that. That was my bad. I had one job, is to click the live button, and I failed to do that. But hey, I had a great time. The Joel. Anytime we can spend time with Joel is a good time because
Yeah.
he's so insightful. I had a conversation with him years ago when we were trying to name an internal thing, and we had like a little focus group. It was a and I was in there with him and a couple other people, and as we're talking about the words that we're considering using for the product, he's going into the etymology of the words, and I'm like,
Mm,
dude, I always learn something when I talk to Joel. So,
that's
I
cool.
yeah, he's a fantastic conversation. So, if you're ever at an agility, if you ever are visiting the tower and you have an opportunity to hang out with Joel for a little while, take him out for a drink, take him out for dinner, and you'll come away much more informed about the way the tech world works. And ask him about rocketry because he's got a lot of skill and interest there as well. So,
Fantastic.
yep. Anyway, Joel, or you're not Joel, you're Boo. Boo, thank you so much for joining me on the show today. And community, always a pleasure. Have a great week, and we will see you out there at community.f5.com until we see you back here next week.
Well, thanks for checking out that video. If you have any questions, leave a comment down below. While you're down there, hit the like button and subscribe if you haven't already. You might want to check out one of these videos over here. And if you haven't already, go check out community.f5.com. This is where all the DevCentral Connects hosts hang out, as well as the rest of the community. It's free to sign up, and we'll see you there.